In the present video, we will discuss the example problem on modified distribution method, that is MODI method or UV method. Let's see the problem. Solve the optimum solution to the given transportation problem by MODI or UV method. Here, given the three supply centers S1, S2, S3 and 4 demand centers D1, D2, D3 and D4, and also given the supply and demand values at respected centers. Let's see the solution. First, observe the given transportation problem is balanced or unbalanced. First, to calculate the total supply. So total supply equal to the 250 plus 350 plus 400, that is 1000. Then calculate the total demand, that is 200 plus 300 plus 350 plus 150. Total demand equal to 1000. Then total supply equal to the total demand. Then given transportation problem is balanced. First step is find the initial basic feasible solution of a transportation problem by any of the three methods, that is northwest corner rule, least cost method and VAM method. In this problem, we have to find out the initial basic feasible solution by applying the northwest corner rule method. In the northwest corner rule method, first to select the northwest corner cell or upper left corner cell in a transportation matrix. Then allocate the minimum value of the demand or supply. Here, northwest corner cell is the S1 row and the D1 column. Then observe the demand and supply. Here, demand is the 200 and supply is the 250. So among these two, minimum value is the 200. So allocate this minimum value of 200 in this cell. Then subtract this 200 from the supply as well as the demand, that is 250 minus 200 equal to the 50. 200 minus 200 equal to the 0. Then remove the D1 column because its demand is 0. Next to select the northwest corner cell, that is S1 row and the D2 column cell, and observe the its supply and demand. Here supply is the 50 and demand is the 300. Among these two, minimum value is the 50. Then allocate this minimum value 50 in this cell. Next, subtract this 50 from supply as well as the demand. Then 50 minus 50 equal to the 0 and 300 minus 50 equal to the 250. Then remove the S1 row because its supply is 0. Next, to select the northwest corner cell, that is S2 row and the D2 column. Then allocate the minimum value of the supply and the demand. Here supply is the 350 and demand is the 250. Among these two, minimum value is the 250. So allocate the 250 in this cell. Then subtract this 250 from the supply as well as the demand. Then 350 minus 250 becomes 100 and 250 minus 250 equal to the 0. Then remove the D2 column because its demand is 0. Next, to select the northwest corner cell, that is S2 row and the D3 column cell. Here observe the demand as well as the supply. So demand is the 350 and supply is the 100. Among these two, minimum value is the 100. Then allocate the 100 in this cell. Then subtract this 100 from supply as well as the demand. Then 100 minus 100 equal to the 0 and 350 minus 100 equal to the 250. Then remove the S2 row because its supply is 0. Next we have to select the northwest corner cell, that is S3 row and the D3 column, and observe the supply as well as the demand. Supply is 400, demand is the 250. Among these two, minimum value is the 250. Then allocate the 250 in this cell. Then subtract the 250 from the supply as well as the demand. That is 400 minus 250 equal to the 150. 250 minus 250 becomes the 0. Then remove the D3 column because its demand is 0. Next, final one, we are having the only one cell, that is the S3 row and D4 column cell. So here demand as well as both are having the same values, that is the 150. So then allocate the 150 here. Then subtract the 150 from the supply as well as the demand. So both will get the 0. So this is the initial basic feasible solution by applying the northwest corner rule. And here all allocations are independent. So the problem is non-degenerate. And the number of allocated cells are the, so 1, 2, 3, 4, 5, 6, which is equal to the m plus n minus 1 equal to the 6. Here m equal to the number of rows and n equal to the number of columns. And total transportation cost becomes the, so 200 into 3 plus 50 into 1 plus 250 into 6 plus 100 into 5 plus 250 into 3 plus 150 into 2. So total transportation cost is the 3,700 rupees. Next step is find the set of numbers ui and vj for each row and column which satisfying the ui plus vj equal to cij for each occupied cell. Here cij equal to cost of transportation for 1 unit of the product from the ith origin or demand to the jth destination or supply. So remember here I represents the rows number and j represents the column number. So here we have to determine the set of numbers, that is ui and vj, by using the relation ui plus vj equal to cij. Remember that we have to use this relation only for the allocated or occupied cells. So set numbers of ui for the rows, here 3 rows are there, so 3 u numbers, that is u1, u2, u3 for the s1 row, s2 row and the s3 row. Similarly, set numbers vj for the columns. Here we are having the 4 columns, so we have to determine the 4 v numbers, that is v1, v2, v3, v4 for the d1 column, d2 column, d3 column and d4 column. So next observe the number of allocations for the rows and columns. Here for the S1 row, number of allocations are the 2, and for the S2 row, number of allocations are 2, and for the S3 row, number of allocations are 2. Similarly, observe the number of allocations for the columns. For D1 column, we are having the only one allocation. For V2, D2 column, we are having the 2 allocations. D3 column, 2 allocations. D4 column, we are having the only one allocation. Next, we have to determine the set numbers by using the relationship of ui plus vj equal to cij for allocated cell. And initially we have to consider any one set number is 0. Here observe that one the S1 row, S2 row and S3 row as well as D2 column, D3 column are having the maximum number of allocations. So among the U1, U2, U3, V2, V3, any one set number we have to consider the 0. So randomly we have to select any one set number is 0 which having the maximum allocations. So here we have to considering the randomly U1 is 0. So next we have to solve the respected row, that is the S1 row, which having the two allocations. Then we have to solve these two allocated cells. Here allocated cells are the S1 row and the D1 column. Similarly, S1 row and the D2 column. And this value is the first row and the first column. So it is the C11. This is the first row and second column. This value is the C12. So first we have to solve the C11 as well as the C12. And we know the relation is, so Ui plus Vj equal to the Cij. So here I represents the row number, J represents the column number. C11 means U first row, U1. So another one is represented the column number, that is the first column. So V1. So U1 plus V1 equal to the C11. We know this C11 value is the 3 and we are considering the U1 value is the 0. So 0 plus V1 equal to the 3. So V1 value is the 3. So next we have to solve the C12, first row and the second column. That C12 value is the 2. Sorry, C12 value is the here 1. And we have to use the relation U1 plus V2 equal to the C12. Initially we are considering the U1 is 0. Then V2 equal to the 1. So next we have to solve the C22. So this is the C22 because we got this value. Then observe the D2 column allocations. So this is already we solved. Then have to solve this one. So this is the second row and second column, that is the C22. So C22 equal to U2 plus V2 equal to C22. So C22 value is the 6 and V2 value is the 1. Then substitute in this relation, we will get the U2 value is the 5. So next we have to solve the C23. So we got the U2 number. Then observe in the second row, allocated cell value. So this is the allocated cell value and this value is the C23. So C23 is the 5. Then we have the relation, that is the U2 plus V3 equal to the C23. Then U2 value is the 5. So 5 plus V3 equal to the 5. Then V3 equal to the 0. So we got the V3 value also. Then we have to solve the C33. So we got the V3 value. Then we have to observe this column. So allocated cell is this is the third row and third column. So this value is the C33. So C33 is the 3. Then we know the relation U3 plus V3 equal to the C33 and U3 plus V3 value we got it, that is the 0. Then we substitute here, we will get the U3 value is the 3. So next we have to determine the V4 value. For this one I have to observe this column. Here we are having the allocated cell and this cell value, this C value is the third row and the fourth column. So this value is the C34. Next we have to solve the C34. So we know the relation is U3 plus V4 equal to the C34. So we got the U3 value, that is the 3, and 3 plus V4 equal to the C34 value is the 2. Then V4 value is the 2. So next step is find the net evaluation value for each empty cell by using the relation is delta ij equal to Cij minus of Ui plus Vj. So here we have to determine the delta values for the empty cells. Here, so these are all the empty cells, so which are the not occupied cells, not allocated cells. So for these cells, so this is not. So for these cells, we have to determine the delta value. So delta ij equal to Cij minus of Ui plus Vj. So first empty cell is the, so this is, so here first row and third column, that is the delta 13. So delta 13 equal to the C13 minus of U1 plus V3. So here this is the C13 value. We know the C13 value, and respected we know the U1 as well as the V3. Then substitute. So C13 value, U1 value and V3 value, that is 7 minus of 0 plus 0. So then delta 13 value is the 7. So next empty cell is the, so this is the next empty cell. So this means delta 14, first row and the fourth column. So delta 14 equal to the C14 minus of U1 plus V4. C14 value is the 4, U1 value is the 0 and V4 value is the 3. Then substitute here, we will get the delta 14 equal to the 1. So next empty cell is the second row and the first column, that is the delta 21. So delta 21 equal to the C21 minus of U2 plus V1. Here C21 value is the 2, U2 value is the 5, V1 value is the 3. Substitute here, we will get the delta 21 value is the minus 6. So next empty cell is the second row and the fourth column, that is the delta 24. So delta 24 equal to the C24 minus of U2 plus V4. C24 value is the 9 and U2 value is the 5, V4 value is the 3. Substitute here, we will get the delta 24 is the 1. So next empty one is the S3 row, that is the third row and the first column, delta 31. So delta 31 equal to the C31 minus of U3 plus V1. C31 value is the 8, U3 value is the 3 and V1 value also 3. Then 8 minus 6 equal to the 2. So delta 31 equal to the 2. Next empty allocation is the third row and the second column, that is the delta 32. So delta 32 equal to the C32 minus of U3 plus V2. So then substitute the C32 value, U3 value and V2 value, we will get the delta 32 equal to the minus 1. So next step is, so observe the delta ij values. If all the delta ij values are the positive, then solution is optimum and unique solution is exist. If all the delta ij greater than or equal to the 0, any delta ij value having the positive as well as the 0, then solution is optimum, but alternative solution is exist. If at least one delta ij value is the negative less than 0, then solution is not optimum and then you have to go for the next step. So here observe the delta 21 and the delta 32 are the less than 0 negative values. So solution is not optimum. Then you have to go for the next step. Next step is, if at least one delta ij is less than 0, then choose most negative value. Here delta 21 and delta 3, 2 are having the negative values. Among these two, most negative is the delta 2, 1, that is the minus 6. So delta 2, 1 mean, so S2 row and the D1 column cell. So initially these cells are having the empty cell. So there is no allocated values. Now we have to change the most to negative delta value cell is allocation value is the plus 6. Here most to negative cell is the most to negative delta cell is the S2 row and D1 column cell. So in this cell we have to allocation value is the plus 6. So here we are allocated the plus 6. So next we have to draw a closed path from this cell and assign the plus 6 and minus 6 sign alternatively. So next we have to draw a closed path like this. So this is the example of the closed path. Then I have to change the allocations, that is the initial one is the plus 6. Next one is the allocation value minus 6. Next one is the allocation value plus 6. Next one is the allocation value minus 6. And for drawing a closed path loop, always you have to start with the plus 6 cell and make a closed path within the allocated cell. So here this is the closed path. Then I have to change the allocation values. Initially we are started at the plus 6. So next allocation will become the allocation value minus 6. So here already having the allocation value is the 250. Then I have to change it is the 250 minus 6. Next allocation is the allocation value plus x. Allocation value is the 50. Then I have to modify 50 plus x. And next one is the allocation value minus 6. Initially it is having the 200. Then I have to change it 200 minus 6. Next we have to determine the x value. So for this we have to observe the allocation minus 6 positions and we have to minimize it. Here minus 6 positions are the 200 minus x and 250 minus x. Among these two values I have to minimize. So minimization of 200x comma 250x equal to the 0. Among these two minimum value is the 200 minus x. So 200 minus x equal to 0. Then x equal to 100. Then substitute this x value in the modified allocated cell values. So substitute x equal to the 200. So here 200 minus 200, here it will become the 0. And here 50 plus 200, it is the 250. And here, so x equal to the 200. So here allocated value is the 200. And here 250 minus 200, it is the 50. So this is the modified transportation matrix. Here we are modifying the allocation values. So next once again I have to determine the set numbers, that is the U1, U2, U3 for the rows, V1, V2, V3 and V4 for the columns. And observe the number of allocations row wise as well as the column wise. Here for the first row, for S1 row 1, second row 3 allocations, third row having the 2 allocations. Similarly for the column wise number of allocations, first column 1 allocations, second column 2 allocations, third column 2 allocations, fourth column having the only 1 allocations. So next we have to determine these set numbers U1, U2, U3 values as well as the V1, V2, V3 and V4 values. For this one initially you have to considering the any set number is 0, that is the maximum allocation set number is you have to consider the 0. Here maximum number of allocations for the S2 row, the respected set number is the U2. So initially I have to considering the U2 is 0. So then I have to solve this S2 row allocated cells So first one is the S2 row and D1 column, that is the C21. We know the relation is U2 plus V1 equal to the C21. C21 value is the 2 and U2 value initially we are considering the 0, then V1 equal to the 2. So next one is the second row and the second column, that is the C22. We know the relation is U2 plus V2 equal to the C22. So U2 value is the 0 and C22 value is the 6, then V2 value is 6. So next one is the S2 row and D3 column, that is the C23. So relation is U2 plus V3 equal to the C23. U2 value is the 0, C23 value is the 5, then V3 value is the 5. So next we have to solve we got so V1 we got it, but anyhow already we solved this one. So next we have to move to we know the V2 value. So this already we solved. Next we have to move to this cell. So this is the C12, first column and first row and the second column. So C12 relation is U1 plus V2 equal to the C12. Then U1 plus V2 value is the 6 and C12 value is the 1. Then U1 will become the 1 minus 6, that is the minus 5. So next we have to solve the C33. So we know the V3 value, then have to move to the allocated cells in the T3 column. So already we solved this one. So we are having the allocated cell is here, that is the S3 and D3 column, that is this value is the C33. So C33 equal to the 5, sorry C33 equal to the 3 and relation is U3 plus V3 equal to the C33. So U3 plus V3 value is the 5 and C33 value is the 3, then U3 equal to the 3 minus 5, that is the minus 2. And finally you have to solve the C34. So you have to, we know the U3 value, we have to determine the V4, then have to observe this allocated cell. So here C34 value is the 2, then relation is U3 plus V4 equal to the C34, U3 value is the minus 2 plus V4 equal to the 2, then V4 value equal to 4. Next step is we have to determine the delta value for the empty cell. Here empty cells are so this is the empty cell and this is one more empty cell, this is, and here this is the empty cell and this is the empty cell and this is the empty cell. For empty cells we have to determine the delta value by using the relationship of delta ij equal to the Cij minus of Ui plus Vj. First empty cell is S1 row and the D1 column. So delta 11. So delta 11 equal to the C11 minus of U1 plus V1. C11 value is the 3 and U1 value is the minus 5 and V1 value is the 2. Then substitute, we will get the delta 11 equal to the 6. So next one is the delta 13. So delta 13 equal to the C13 minus of U1 plus V3. So C13 value is the 7, U1 value is the minus 5, V3 value is the 5. Then substitute, we will get the delta 13 equal to the 7. Next one is the delta 14, C14 minus of U1 plus V4. So C14 value is the 4, 4 minus of minus 5 plus 4, which is equal to the delta 14 equal to the 5. So next to empty cell is the second row and the fourth column, that is the delta 24. So delta 24 equal to the C24 minus of U2 plus V4. So C24 value is the 9 and U2 value is the 0, V4 value is the 4. Substitute, we will get the delta 24 is the 5. Next to empty cell is the third row and first column, that is the delta 31. So delta 31 equal to the C31 minus of U3 plus V1. So here C31 value is the 8 and V3 value, U3 value is the minus 2 and V1 value is the 2. Substitute, we will get the delta 31 equal to the 8. Next to empty cell is the third row and second column, that is the delta 32. So delta 32, C32 minus of U3 plus V2 here. C32 is the 3 and U3 is the minus 2 and V2 equal to the 2. Substitute, we will get the delta 32 equal to the minus 1. So next observe the delta values. If all the delta values are the positive, then we get the optimal solution. But here, so delta 32 is the negative one. So we are not getting the optimal solution. Then once again I have to repeat the same procedure. So I have to go for the next step. Next step is, if at least one delta ij is less than 0, then choose the most negative value. Here, only one delta value, that is the delta 32 value, is the negative value, that is minus 1. Then I have to choose the delta 32, which means we have to choose the cell S3 row and the D2 column, and we have to allocate the, in this cell allocation value is the plus x. So initially in this cell having the no allocation, now we are giving the allocation is, that is the plus x. So next we have to draw a closed path from this cell and assign the plus x minus x sign alternatively. So this is the closed path. Next we have to change the allocation values. Initial one is the plus x. Next one is the allocation value minus x. It is having the 250. Now it is the 250 minus x. And next one is the initial allocation is the 100. We have to change 100 plus x. And next one is initial allocation value is the 50. Now once again I have to change it 50 minus x. So next I have to find out the x value. For this one I have to check the minus x positions and I have to minimize it. Here minus x positions are the 50 minus x and 250 minus x. Then I have to minimize this one. So minimization of the 50 minus x comma 250 minus x equal to the 0. Among these two, minimum value is the 50 minus x equal to 0, then x value equal to the 50. Then I have to substitute. So x value, so in the allocated values. Now once again allocation values will be changes into the, so here plus x value is the 50. So here it will be changed into the 50. Then here 250 minus x, it will become the here 200, this allocation value. Here 100 plus x equal to 50 mean here 150. 50 minus 50. So here it is the 0. So now this is the, so modified allocated transportation matrix. So next once again I have to determine the set numbers, u values and the v values. So based on the relationship is ui plus vj equal to the cij. We have to use this relation only for the occupied cell. First, I have to observe the number of allocations row wise and the column wise. First row, so S1 row having the only one allocation, and the second row, next to determine the set numbers u1, u2, u3 and v1, v2, v3, v4. And initially you have to consider the maximum allocation set number is 0. Here maximum allocations are for the S3 row. So respected set number is U3. So U3 we are initially considering the 0. Then I have to solve the S3 row which having the 3 allocation cell. So first we have to solve the C32. So third row and second column C32. Relation is U3 plus V2 equal to the C32. C32 value is the 3 and U3 value is the 0, then V2 is the 3. Next we have to solve the, so third row and the third column, that is the C33. So C33 equal to the U3 plus V3. We know C33 value is the 3 and u3 value we are considering the 0 and v3 will become the 3. Next, so third row and fourth column, that is the C34. So C34 equal to the U3 plus V4, and C34 value is the 2 and V4 will become the 2. So next we have to solve the C12. So have the relation U1 plus V2 equal to the C12. Here C12 value is the 1 and V2 value is the 2. Sorry, V2 value is the 3. Then U1 we will get the minus 2. So next we have to solve the C23. Relation is U2 plus V3 equal to the C23 and V3 value is the 3 and C23 value is the 5 and U2 value will become the 2. And finally I have to solve the C21 to determine the V1 value. So relation is U2 plus V1 equal to the C21. Substitute C21 value and U2 value, then V1 value is the 0. Next we determine the delta values for the empty cells. First empty cell is the 1 1. So S1 row and the D1 column, delta 1 1 and delta 1 1 equal to the C11 minus of U1 plus V1. Substitute all these values, we will get the delta 1 1 value is the 5. Next empty one is the first row and the third column, delta 1 3. So here also substitute C13 value and U1 V3 value, we will get the delta 13 equal to the 6. Next one is the delta 14. So here also we know the C14 and the U1 value, V4 value, substitute, we will get the delta 14 equal to the 4. And next to empty cell is the second row and second column, that is the delta 22, which is equal to the C22 minus of U2 plus V2. Substitute all these values, we will get the delta 22 equal to the minus 1. Next to empty cell is the second row and fourth column, that is the delta 24. So here delta 24 value we will get the 5. Next one is the third row and the first column, delta 31. So delta 31 equal to the C31 minus of U3 plus V1, which is equal to the 8 minus of 0 equal to the 8. So here observe the all the delta values are the positive values. All are having the greater than 0. Then solution is optimum and a unique solution. So this is the optimal solution. These allocated are the optimal allocations. Then total transportation cost will become the, so 1 into 250 plus, 2 into 200 plus, 5 into 150 plus, 3 into 50 plus, 3 into 200 plus, 2 into 150. Then the total transportation cost becomes the 2450 rupees. And this is the solution, and thank you.